All right, for numbers 9 and 10, we're going to find the general solution of each differential equation. These are both separable differential equations, which means we can separate the variables to opposite sides. So we can get the y's on one side and the x's on the other side. So that's what we'll do. Then we'll integrate both sides and we will solve for y. That's really the gist of these type questions. So let's go ahead and get started. We'll go ahead and multiply both sides by e to the 2y. I'm going to cross out the 9 just so it's not in the way. So e to the 2y. That will get the y's to one side, and then we'll multiply both sides by dx. And that will get the x's to the right side. So dx's cancel on the left. We're left with e to the 2y. dy equals, these cancel, 2x dx. Now that we've separated them to both sides, we go ahead and integrate both sides. These are fairly simple integrals. This is e to the 2y, so the integral of that's going to be e to the 2y, but we will have to realize that we need to deal with this 2 here, so it's going to be a 1/2 out front. You can go ahead and check that if you want to make sure that's the correct integral. So we have plus, and I'm going to put c sub 1 because that's a constant there. But we're going to be working with constants throughout. We can just have different constants. The next one, the integral of 2x dx, well, that's just x squared plus some constant, so I'll put c sub 2. So here we integrated. Now we want to just solve for y. We'll go ahead and get the c's to one side, so I'm kind of going to be subtracting c sub 1 from both sides. And when we do that, we get 1/2 e to the 2y equals x squared plus some other c value, so I'm just going to put a c sub 3. We're then going to go ahead and multiply both sides by 2 to get rid of that 1/2, and we'll distribute that through. Distributing that through, the 2 cancels, we have e to the 2y equals 2x squared. 2 times a constant is still some constant, so we're going to put a c sub 4. Because it's another constant, but doesn't really matter what it is. And then now that we have this, we're going to go ahead and change to log form because we need to solve for y, which was in the exponent. So we'll change this to log form. So this is log base e, so natural log base e of 2x squared plus, and now I'm just going to put c because we're done messing with this c. It's not going to get changed anymore. So natural log base e of 2x squared plus c equals 2y. We can then go ahead, we can do a couple different things. We could divide by 2 or we could multiply by 1/2, and we get y equals natural log of 2x squared plus c all over 2. And there is a general solution for that differential equation. Moving on to number 10, it's going to be very similar. Again, it's I'm going to get that out of the way. It's separable, so we can multiply both sides by y squared. To get the y's to the right side, we can multiply both sides by dx to get the x's. Sorry, I said that wrong. Y's to the left side, x's to the right side. So this is y squared dy equals e to the x dx. And again, that's because these canceled and these canceled. And now we're going to integrate both sides. Over here we get 1/3 y cubed plus some c value equals, and the integral of e to the x is just e to the x plus some c value. Subtract a constant from both sides, which will give us a different constant, so we have 1/3 y cubed equals e to the x, and again what I'm doing is I'm subtracting some constant from a constant and getting just a different constant. So we'll call that some constant c sub 3. don't think we'll have to mess with that c anymore, but so now we're going to multiply both sides by 3 to help us solve for y. We have y cubed equals 3 e to the x. Oh, I was wrong. We get a different constant again, so c sub 4, because 3 times a constant is a different constant, and then we can take the cubed root of both sides to finish this solving for y. So our answer is y equals the cubed root of 3 e to the x plus some c value.